Hi there, I'm Anthony Felici, captain of the ROV project for Sea Scout Ship 41. Today is February 9th, and this is our physics lesson of the day for fluid dynamics. What we have here is we're trying to find the amount of force needed to hold up a piece of PVC we have to pick up off the bottom of the pool, so we don't use too much pressure in the cylinder. And it takes a bunch of steps, but there's actually a way to find that out. What you need to do is you need to find the amount of water weight that the object has when underwater. This is done by finding the force buoyancy, or force of gravity, minus the force of buoyancy, and that is rho Vg for buoyancy, which is the density of the PVC, of water, times the volume of water displaced times the force of gravity. And once you find that and the force of gravity, which is mass times gravity, you subtract that, you get the summation of forces in the y direction. And you can use that to find an equivalent dry weight slice of PVC made of the same density PVC and whatnot. So when you're picking it up, the amount of friction minus the force of gravity is going to be equal. That's how you, otherwise it'd be shooting out the top of the thing or falling out of the graspers. And because of the design we have here, when they're equal, there's going to be a certain amount of force being pulled to keep this end effector closed. Now we can find that using a force gauge. Pasco makes those. And when you have that amount of force, that's the same amount of force that's going to be in the piston. Now, this is when you can start finding out the amount of force you need in the air cylinder. You do this with Bernoulli's equation, which is the pressure initial plus rho GH initial plus 1/2 PV squared initial equals pressure final plus rho GH final plus 1/2 rho V squared final. Because there's no flowing fluids, we can cross out this on both sides, and you're just left with pressure 1 equals pressure 2. And pressure equals force over area. Now, the amount of force, we have the area here that's known, that's of the cylinder head. We have the area of the intake hose, and we have found the area, the force for the piston. So what's missing is the amount of force in PSI or pascals coming into the air hose. So we just, by simplifying it, we can separate the fraction, get it into FA times A area B equals force B times area A. And then you can simplify that more by putting into force A times area B over area A equals the force B, and that's how you find how much force is needed coming into this air hose here.
Good.
Yeah.